Welcome back to eCoreAcademy, students. My name is Anita Raj, and I am one of the teachers and co-founders here, along with my younger brother, AJ. As you can see, today we'll be doing a new Algebra 2 lesson as we progress through our quadratics unit. You may be familiar with quadratics from Algebra 1, but the reason we're doing it again in Algebra 2 is because we're trying to look at quadratics through the lenses of a higher level math student. This is my motto. This is what I say every single time when you might be wondering why we're repeating a topic. So all these topics with quadratics you've probably seen, spare for the ones that include a TI calculator when you were in Algebra 1, including the one we're going to be doing today, completing the square. So you've probably seen it, but I remember when I took Algebra 2, I barely remembered completing the square. So this is really meant to jog your memory. So we are going to do a quick recap of completing the square and just like looking through it in the perspective of a higher level math student. So just looking how we can apply completing the square to different problems, how to approach different problems when we're factoring, and deciding what is the smartest way to solve this problem so we're not wasting time when we're on assessments, and we are making sure that we're using the method that can get us to the right answer that has the lowest percentage of error. So as you can see, we're going to be looking for ways to manipulate quadratics so we can solve them by factoring. So manipulate pretty much means just make something do what you want it to do. And that's what we're going to be doing with these quadratic equations. And the reason we're doing that is so that we can make them factorable. So you might be confused by what that means right now, but when I get into the video, I'll show you exactly what I mean by that statement. Before we even get into the content, I would really appreciate it if you pause the video and like the video. Please also subscribe to the channel to join our student community, and don't forget to hit the post notification bell. Drop a comment if you would like, and please share using our socials, which you can find in the description box below. Okay, let's get right into our topic. So first, I want to go over what is completing the square. So completing the square, as you can see a highlighted term on the screen, is manipulating a quadratic to force a perfect square trinomial enabling factoring. So let's break this down. Manipulating a quadratic. So what does that mean? We're changing a quadratic around. We're making it look the way we want it to look. We are adding terms, we're subtracting terms, but we're keeping the equation balanced as much as possible. So whatever we do to one side of the equation, we're doing to the other side of the equation. So everything stays balanced and we still get the right answer. So we're manipulating a quadratic. How are we manipulating a quadratic? Well, we're forcing a perfect square trinomial. And if you forgot what a perfect square trinomial is, I'll go over it later on in this slide. But the reason why we are manipulating the quadratic is because we want to get a perfect square trinomial, because this will enable factoring. So that answers the why part. So why are we doing this? So to enable factoring. Let's say you don't have a calculator, so you can't solve these quadratic equations with a calculator. So your go-to option would be find a way to factor it. So what if it's not factorable? What if you're given a quadratic equation where you try GCF and you can't GCF? You're breaking your C term down into its factors, but none of them add or subtract to your B term. Nothing is working at all. Well, then you might try completing the square. And trust me, you're going to run into these scenarios on assessments. So you might try completing the square to force a solution so that you can actually find the solutions of x. So that is what completing the square is. Hopefully you remember what perfect square trinomials are, because they are going to be playing a big part in this. And if you don't remember, that's okay. I totally understand if you're still getting used to the term. So perfect square trinomials is when you're taking one binomial expression and multiplying it by itself to get a trinomial of the form ax squared plus bx plus c. Hopefully you recognize this ax squared plus bx plus c, because this is your standard form. This is written in your standard form. You usually have it equals y or equals 0, but let's just call this our standard form of a quadratic equation. So what is a perfect square trinomial? So you're taking one binomial expression, multiplying it by itself. So a binomial expression is the sum or difference of two terms. So if you think of a set of parentheses, a binomial would look something like this. In the set of parentheses, we have two terms. We have x and 1. And they're both separated by either an addition sign or a subtraction sign. In this case, it's an addition sign. So a perfect square trinomial is where we take one binomial like this x plus 1, for example, and we multiply it by itself. And the reason we do this is because there's already a set formula. We already know that this is factorable when we get the ax squared plus bx plus c term. So it's just something that's familiar to us and that's easier for us to work with. So that's why we use perfect square trinomials. And these are the two types you will see. You can either see a squared plus 2ab plus b squared. Your a is going to be one of your terms. For example, when you look at this x plus 1, x plus 1, your a squared term could be your x, and then your b term could be, your a term could be your x, and your b term could be your 1. So in this case, it would be x squared plus 2 times 1 times x would be just 2x, plus b squared, b is 1, so 1. So then if we just wrote this all out, it would be x squared plus 2x plus 1. And this is equal to your x plus 1 squared. If you look at this, the only difference is that this first perfect square trinomial has an addition sign. This one has a subtraction sign. So therefore, it's just equal to the difference of two terms. So in this case, we would have something like x minus 1 times x minus 1. And if you just square them, you'll get this. So a squared, let's say a is our x, and then b is our negative 1. And then b is our 1, sorry. And then you do the exact same thing we just did with this this first perfect square trinomial up here. They both work. Those are just two examples for you, but these are perfect square trinomials, and like I said before, they're going to be playing a big part into completing the square. Okay, let's go to the next slide. So now I'm going to go over how do I do it, and I'm going to give you the instructions. So if you're taking notes on this, maybe copy these instructions down if you want to. And then it's okay if you don't get it, because then we'll be going through a few practice problems, 3. And then as we go through them, you'll be able to see how you can apply these steps. You might not follow these exact steps, but these are like super thorough steps that in case you are trying to go through a checklist every time you do a problem, these would be the kinds of steps you look to for the most precision. So how do I do it? So here's the key concept that I want you to keep in mind. You're to solve by completing the factor when ax squared plus bx plus c equals 0. So remember, your equation's also always going to be equal to 0, and you're completing the equation. So you're messing the equation up, and then you're filling in the equation wherever you messed it up, if you want to think of it in terms like that. So you're completing the equation. So first you want to rewrite the equation in the form x squared plus bx equals c. So if you look over here, we have ax squared plus bx plus c equals 0. If we want to get it to x squared plus bx equals c, what are we doing? Well, we are first dividing by the a term. If you can see here, the a term has disappeared. Divide by a. And then if you see, we've moved the c to the right side of the equation. Therefore, if c is positive, we subtract c from both sides of the equation, and if c is negative, we're adding c to both sides of the equation. So we're trying to move c to, that's why I say plus or minus c, so you're adding or subtracting c to both sides of the equation. We're just trying to move c to where the 0 is. So we're trying to divide by a first, and then we're moving c to where c to where 0 was, so then you get x squared plus bx equals c. Like I just said, if a does not equal 1, then you want to divide by a. So if it doesn't equal 1, you want to divide by a. So you're dividing your a term by your a term, your b term by your a term, and your c term by your a term, so you can get rid of whatever coefficient is with your x squared term. Then the part where completing the square is the place where you're completing the square is right here in this step. So you want to complete the square by adding b divided by 2 and that quantity squared to each side of the equation. So you're going to have to memorize this b over 2, that quantity squared. That's pretty easy. So what you're pretty much doing is, as you can see here, you have this x squared plus bx equals c. So what you're doing now is you're taking you have this right side of your equation plus bx. To complete the square, you need that constant on your left-hand side of the equation, because what you're trying to do is you're actually trying to force a perfect square trinomial. By dividing your b term, whatever it is, by 2 and squaring it, and adding that to the left-hand side of the equation, you're going to get a trinomial that is a perfect square trinomial. So you are forcing the perfect square trinomial. You are manipulating your b term and adding it to both sides of the equation to force that. So you're just adding a number in there that wasn't originally in there to complete the square and force factoring. So then what's going to happen is you're going to have x squared plus bx. Then you're going to have that plus b divided by 2 squared, and then that's going to equal whatever your c term was. But you also have to add that b over 2 because you need to balance both sides of your equation. So you're adding that b over 2 squared term to both sides of your equation, and then you'll be forcing a perfect square trinomial. Then you want to factor the trinomial on the left-hand side of the equation. Like I told you, whatever you get here is going to end up being a perfect square trinomial. So I'm going to write it underneath it. Perfect square trinomial. So whatever you get here is going to be a perfect square trinomial. And you can just factor this simply by dividing it into something like a plus b squared, that quantity squared, or you're going to get a minus b squared. And that just depends on the sign between the sign that would go between your x squared and your bx. So just depending on that sign, you'll get a plus b squared or a minus b squared. Next, you want to find the square root. So then you're going to have something like a plus b times a plus b on your left-hand side of your equation, or you're going to have something like a minus b times a minus b on the left-hand side of the equation. And then this is going to equal a constant. So c is going to be your constant. Remember, c is on this side of the equation. And then this b over 2 squared is going to be another constant. So you're going to be adding these two constants together, and you're going to get a constant. Maybe it'll be negative 1/2, 5, 10, negative 100, something. And then what you're going to do is, because you want to square root the left-hand side of the equation, meaning you want to get rid of this squared, because remember there are two a plus b expressions, there are two a plus b binomials being multiplied together. So you want to square root it to get rid of one of them. So you're going to be square rooting the left-hand side of the equation, but what you do to the left-hand side, you need to do to the right-hand side. So you're also going to be square rooting the right-hand side of the equation. And then after that, that's why it says finding square roots. So even if it's not a perfect root, you got to just simplify it into like a radical form. So you're just going to square root both sides of your equation, and then you're going to solve for x. So that'll just make it much easier. And then you'll have something like a plus b or a minus b equals some constant value, and whichever one in this a or b, whichever one is x, is going to remain on the left-hand side of the equation, and then the other one will always be a constant. So you'll either add or subtract it from the left-hand side of the equation, so you can get x by itself, and then you will get a constant. You'll get x equals some number. So that is how we do completing the square. Those are all the steps. And if you're confused, that's totally fine. I totally understand that. We got to run through some examples for you to get the gist of how to do this. So here's the first example. What value completes the square? Fill in the missing value. So this is going to be our easiest one. All we're doing is we're not solving anything. We're not factoring anything. We're just getting used to completing the square. As you can see, this isn't even an equation. This is an expression because we don't have any equal sign. We don't have x squared plus 8x plus some value equals 0. This is totally a simple problem. We're just getting used to that b over 2 squared. We're getting used to implementing this into forcing a perfect square trinomial so that we can solve. So here's the solution already pre-written for you. So if you're a kind of person who likes to copy stuff down before the teacher goes over it, and then the teacher goes over it, so you just listen as they do that, so you're not worrying about copying down while the teacher's talking, go ahead and copy that down, and so you can pause the video and you can jot this down wherever you're taking notes, and then it'll go off the screen, and then we will do this problem together. So hopefully that was enough time. It's going to dart off the screen, fade out of the screen. So now we're going to be doing this together. So our first step is always going to be rewriting the problem. So the problem is x squared plus 8x plus whatever this blank term is. So remember, this is going to be usually our c term. And remember, the first step was we divide by a if a is not equal to 1. In this case, a is equal to 1, so we don't have to worry about that. Then we subtract c from both sides. As you can see, we don't even have a c term. We're going to assume that the c term was already subtracted, but then we got rid of that equal sign, and now we're just looking at an expression. So this is an incomplete expression because we don't have a constant value here to complete the square. Therefore, we need to force a constant value. And hopefully you remember this little formula from the last slide, this b over 2 squared. So that is what we're going to be using to find out what this blank space is. So let's do this. B over 2 squared. So what is our b term? Our b term is 8. So b is equal to 8. Therefore, let's plug 8 into this. So 8 over 2 squared. That's what we're trying to find. This is equal to 8 divided by 2 is 4. So this is 4. And then we're squaring that. and 4 squared is equal to 16. So 16 is our constant. 16 is what is going in this blank space right here. Therefore, if we're going to complete the square to find this missing value, we get x squared plus 8x plus 16. So 16 was what we are looking for. So if you wanted to factor this, let's just say we're trying to factor this quadratic expression. Take note, it's not an equation, so we're not solving for anything. We're just factoring it. This is the answer, just so you know. But the 16 is the answer. But let's just take it a step further. So if I was trying to factor this, I want you to take a second to think about how would I factor this. Remember, this is a perfect square trinomial in the form a squared plus 2ab plus b squared, because see, there's this sign right here is positive, so that's why we get the plus 2ab. So think about it for a second. How would we factor this perfect square trinomial? Okay, so if you look up here, we have this 8 divided by 2 equals 4. So this value right here, your b, whatever your b is divided by 2, is going to be in those set of parentheses. So what do I mean? So if we factor this perfect square trinomial, we'll get x plus 4 times x plus 4, which the 4 we got up here because we divided our b value by 2. Or you can just rewrite this as the quantity x plus 4 squared. So I want you to take that into consideration, take that into note. That's going to be important. So when we factor, whatever value goes in the parentheses with the x is going to be whatever your b value was from this original quadratic expression divided by 2. Because remember, it's a perfect square trinomial. And if you multiply this out, x times x is x squared, x times 4x is 4x, 4 times x is 4x, 4x plus 4x gives you the 8x, and if you just multiply the 4 and the 4, you get 16. So this does multiply out to this perfect square trinomial. So I want you to keep that in mind as we go through this. So let's go to the next problem. This is where we actually start incorporating completing the square. And sometimes completing the square can get a little bit messy, but stick with it. It will be a bit of a struggle at first. I know it definitely was a harder concept for me, but you'll get the hang of it if you just do practice problems. So here's I'm asking you to solve by completing the square. So here is the quadratic equation I've given you, because you can see it's equal to 0, so you have an equal sign. So it's 4x squared minus 16x plus 8 equals 0. So I'm going to tell you right now that you're solving by completing the square because pretend you're on an assessment right now and you're looking at this problem. You've already checked it and you see that you can't factor it normally. There are no factors of 8 when multiplied between 4 and 1 or 2 and 2, because remember, I'm splitting my a term up. There's no way to factor this. So you can't split this into 2 factors. It's not factorable. Therefore, if we really want to solve it by hand, we need to force a perfect square trinomial. And how will we do that? Well, we're going to be following the steps of how to complete the square. So here is the solution written out. It looks a little bit lengthy, I know, but these are all the steps you're going to have to follow. And just so you know, especially if you're taking like an honors level algebra 2 class, your completing the square problems are going to be messy. I'm just going to tell you that right now. They are going to be difficult. They are going to be messy. If you see the answer down here, we have a radical sign. So because root 2 is not a rational number, we have a radical sign. So you need to understand those concepts. And as we go through quadratics, you will, but just be aware of that so you're not overwhelmed. So copy that down if you want to. I'm going to be going through it anyway. Okay, hopefully that was enough time. That's going to go off the screen so we can do this problem together. So first, let's rewrite this quadratic equation we have. So 4x squared minus 16x plus 8 equals 0. So our first step is going to be looking at the a term. Our a term is 4. 4 is not equal to 1. So we need to divide our a term, our b term, and our c term by 4. Luckily, in this case, all of them are divisible by 4. So if I divide all of these terms by 4, 4x squared divided by 4 is just x squared. Negative 16x divided by 4 is just negative 4x. And then 8 divided by 4 is 2. And whatever we do to the left-hand side of the equation, we need to do the right-hand side. Luckily, 0 divided by any number is equal to 0. So 0 divided by 4 is just equal to 0. And this second quadratic equation that we have, it's equal to the first one because we divided everything by the same term. So they're both equal to each other. Next, what we have to do is we need to move our c term, which is 2 in this case, to the right-hand side of the equation. To do that, we're going to subtract 2 from both sides. I'm just running through the steps that I showed you on an earlier slide. So we're going to have x squared minus 4x, and we're going to subtract 2 from both sides. So this equals negative 2. Now, as you can see, we're missing that c term now on the left-hand side of the equation because remember, we're doing all of this to force a perfect square trinomial. So we're trying to find a c term that when added to the left side of the equation will make the left side of the equation a perfect square trinomial. How do we do that? Remember the b over 2 squared. So now that comes into play. So b over 2 squared is equal to, b in this case is negative 4. So we're going to have negative 4 over 2 squared. Negative 4 divided by 2 is negative 2. Don't forget that negative. It is important. And then negative 2 squared is equal to 4. So what we're going to do with this 4 is we're going to add it to both sides of this equation. So we're going to get x squared minus 4x. And we're going to add 4 because we have to add it to both sides of the equation. I see a lot of people mess up on completing the square because they don't add this b over 2 squared term to both sides of the equation. Remember, whatever you do to the left side of the equation, you must do to the right side. Therefore, you need to add 4 to the negative 2. Negative 2 plus 4 then makes this a positive 2. So now we have this. Where do we go from here? Well, I want you to recall what I told you on the last slide. So we want to factor this because this is a perfect square trinomial. We already know that we forced the perfect square trinomial by doing this b over 2 squared. So what do we put in the parentheses? Remember, we're going to in this case, because it's minus 4x, we're going to have this kind of perfect square trinomial. A squared minus 2ab plus b squared, which you can see right here. However, when we're trying to break this into its factors, into a minus b, we're going to say our a is our x because in this case our a is usually our x. But what is the b? What constant represents the b? Well, the constant that represents the b in this case would be what b is divided by 2. Remember the last slide. So it's pretty much this value right here, this negative 2. So if we're trying to break this perfect square trinomial into its factors, we get x minus 2, that quantity squared. So this is just equal to x minus 2 times the quantity x minus 2. And if we multiplied it out, we would get x squared minus 4x plus 4. See how I didn't have to do any extra work to get that minus 2? I just knew from the last slide, after I explained it from the last slide, that b, whatever your b is, divided by 2 is going to be what you put in these parentheses when you're breaking your perfect square trinomial into its factors. So we know the left-hand side is this, and we know the right-hand side is just going to be equal to 2. We're just going to bring that 2 down. Well, remember how I said we're going to square root both of the sides to get x minus 2 to get rid of that extra binomial? So that's exactly what we're going to do. We're going to square root because remember at the end of the day we're trying to solve for x. So we're going to square root both sides of this equation. So then if you square root this, the square root cancels out with the squared term, so you just get x minus 2. However, when you square root the right-hand side of the equation, 2 doesn't have a perfect square root, so we're just going to write the root. We're going to just write root 2, and this can be positive or negative root 2. Remember, with quadratics, you typically tend to have 2 solutions, so you can either have plus or minus. In this case, I just want you to know the positive root is the principal root, and the negative root is just your other root. So you can usually have 2 roots, and with quadratics, you usually have 2 solutions. So don't forget that plus or minus. Then to get x by itself, you want to add 2 to both sides of the equation because we see this minus 2, we want to get rid of it. So if we add 2 to both sides of the equation, we can rewrite this as 2 plus or minus root 2. So x is equal to 2 plus root 2, whatever that is, or x is equal to 2 minus root 2, whatever that is. And this is our solution. So that is how we use completing the square to solve this problem. Okay, let's move on to the third and final problem. So in this problem, it's going to be a little bit different. Now we will be completing the square to rewrite in vertex form. So hopefully you remember vertex form. Here is the quadratic equation. It's written in standard form, ax squared plus bx plus c. You see y equals x squared plus 10x plus 15. Our a term is 1, our b term is 10, and our c term is 15. So let's see, how can we complete the square to force this to become a perfect square trinomial so we can rewrite it in vertex form? Here's a solution pre-written for you. If you'd like to copy that down, go ahead. Hopefully that was enough time for those of you who wanted to copy it down. So now let me write the solution and work through this with you. So first of all, what is vertex form? Hopefully you remember it from quadratics. This is our standard form, because remember, we've been working with this a lot. Hopefully you remember. Y equals ax squared plus bx plus c, and this here is our vertex form. So vertex form, and vertex form, just to jog your memory, is y is equal to a times x minus h squared plus k. And remember, hk, that point is the point of the vertex. So h represents the x coordinate of the vertex, k represents the y coordinate of the vertex. So how in the world are we going to be changing this standard form into vertex form? But instead of doing it like we would normally do it, there is another way to do this, and that would just be doing, if you remember, your x is equal to negative b over 2a, and your y, for your y value, you just plug the x value back into the function, you figure it out. Well, that's the normal way to do it. There's also another way to convert this, and it would be by completing the square. So let me show you exactly how we're going to do that. So I'm going to rewrite our actual equation, y equals x squared plus 10x plus 15. So what do we want to do now? Well, we already see that our a value is equal to 1, so we don't have to divide by a. That means we need to get rid of 15 on this side of the equation. Therefore, we're going to subtract 15 from both sides of the equation. Remember, we're trying to get rid of our c term that's already there, because if you look at this, we can't factor this. The factors of 15 are 1 and 15 and 5 and 3. There's no way you can manipulate those to add or subtract to 10. So this is not factorable. That's why we're trying to force a perfect square trinomial by completing the square. Therefore, we're going to subtract 15, which is our c term, from both sides. If we subtract 15 from this side of the equation, we get y minus 15. Do not neglect the y. The y is important. So y minus 15 is equal to x squared plus 10x. So now we got to fill in this gap. Whatever goes right here, we need to fill that gap in. And we're going to be using our b over 2 squared, that formula. So in this case, b is equal to 10. b is equal to 10. So we're going to be doing 10 divided by 2 squared is equal to 5 squared, which is equal to 25. Therefore, if I rewrite this, if I add 25 to both sides of the equation, if I add 25 to this side of the equation, we're adding 25, which is a constant term, and negative 15, which is another constant term. So negative 15 plus 25 is equal to positive 10. So that would become y plus 10. And because I'm simply just adding 25 to the right-hand side of the equation, I just get x squared plus 10x plus 25. As you can see, this is a perfect square trinomial on the right-hand side of the equation. And if you want to factor this, which we are going to do, if I just bring this down, y plus 10, and I want to rewrite the right-hand side of the equation, the perfect square trinomial, in factored form, I look at the b divided by 2. b divided by 2 is equal to 5. And because we have a positive sign here, this perfect square trinomial is going to be a plus b squared, not a minus b squared. Therefore, it's going to be x plus 5, because b divided by 2 is 5, plus 5, that quantity squared. And the last step is going to be subtracting 10 from both sides, and I'll explain why after I do it. So if you subtract 10 from both sides, you get x plus 5, that quantity squared, minus 10, because you're subtracting 10. This would be your answer, and you might be confused as to why that is your answer. Well, I want you to look back up to vertex form. Vertex form is y equals a times the quantity x minus h squared plus k, and compare it to our answer. Just take a second to do that. Hopefully you see the similarities. So first of all, our answer is in vertex form. So your a term is equal to 1. Your x is your x. Your h is going to be -5, but if you put it into this equation, it becomes +5. We already have that x and that 5 in a set of parentheses squared, so we already have that part of vertex form, and then your k is equal to -10. So by completing the square, we don't have to do any additional steps past that because we already wrote it in vertex form. So that is how you can do conversions from standard form to vertex form by completing the square. Hopefully that was helpful. So just a quick recap, we went over what is completing the square, we went over the specific rules on how to do it, and then we did 3 practice problems together. So that was this video, and I hope you enjoyed it. If you did, I would really appreciate it if you liked the video, subscribe to the channel, hit the post notification button, dropped a comment down below of what you thought, and shared using all of our socials, which are also in the description box. Our socials include Facebook, Twitter, and Instagram. You can check on there for updates about any videos that come out. If you have any personal or business correspondences, please reach out to us at our Gmail, which is eCoreAcademy@gmail.com. And lastly, please look out for our website, which will be coming soon. Hope you all enjoyed that video, and I will be seeing you next time with another Algebra 2 lesson. Bye!